All right, this lecture is going to be on cyclones and anticyclones, but we're going to focus on cyclones. This is just a low pressure system, and they have this counterclockwise rotation. It's going to be consistent with what we learned with the Coriolis effect. So here we go, cyclones and anticyclones. Cyclones are associated with rising air or low pressure, and they generally bring clouds and precipitation. So if air is converging or coming together, it's eventually going to rise. So low pressure, we find air moving from higher pressure into lower pressure, so therefore it should make sense to us that air is moving towards the low pressure system. Where an anticyclone is just the opposite of low pressure. It's a center of high pressure, and this is generally stable conditions here. We have air that's subsiding, and it's going to create these conditions of essentially stable air. It's going to be generally clear conditions. And we like high pressure. High pressure brings sun most of the time. And pressure increases toward the center. The high pressure is located right here, just as the low pressure is the centermost part of the cyclone. So cyclone is low pressure, anticyclone is high pressure. And I want to pay attention to what's happening with high pressure. If air is sinking here, it can only go one place, and that's out. And then notice it's deflected to the right due to Coriolis. Notice low pressure. Air is always pushed from high to low. So that means higher pressure outside here. It's being pushed towards the low pressure system. And in this case, if it's being pushed and it's deflected to the right, we get this net counterclockwise location or counterclockwise direction. And here just reiterates that. Here's our cyclone. Low pressure is a cyclone. So what is it? Well, a cyclone is the center of low pressure. Pressure decreases towards the center, where the centermost part will be the lowest pressure of them all. Winds associated with the cyclone in the northern hemisphere, they are inward. They move inward toward the low pressure. And they move counterclockwise. So we get this very distinctive pattern here. Think of it this way. Air wants to move straight in. It's deflected to the right because of Coriolis. And so in northern hemisphere, cyclones move counterclockwise around the low pressure. In the southern hemisphere, it's the opposite. They still move inward, but they move clockwise. Let's see here. Anticyclones, high pressure. Notice that we have air that's sinking from high elevation downward, and it's pushed outward. It's deflected to the right due to Coriolis. So in the northern hemisphere, air flows outward. It flows away from the high pressure. Remember, this is what's creating the pressure gradient force, high to low pressure. And they're deflected right because of Coriolis. In the southern hemisphere, it's just the opposite. That anticyclones are associated with subsiding air, air that is descending from high elevation or altitude downward to the Earth's surface. And once it hits the Earth's surface, it can't go anywhere but outward, and then it gets deflected. And it usually brings this fair weather. Think of adiabatics, and is decreasing the relative humidity. As air is descending, it's heating, it's driving down relative humidity. We generally don't have the humidity for forming clouds or precipitation. So high pressure, this air that's descending is warming adiabatically, right, at the dry adiabatic lapse rate, and it travels enough distance from elevation that's going to warm it up enough to clear out the skies. So cyclonic and anticyclonic winds in the northern hemisphere. Here's a picture of a cyclone. Here's a picture of an anticyclone. Cyclones we're calling low pressure systems where air moves counterclockwise around them. And anticyclones are our high pressure systems where air moves clockwise around them. Be sure to follow the isobars in the picture as we reiterate the concept of air moves from high to low pressure. High to low. Low is outside of the high pressure, so it's going to move straight out and to be deflected right. And we see these arrows moving clockwise as a result of Coriolis and your pressure gradient force. And it gets deflected here, Coriolis we say. So we see the circulation around the cyclone. Here's my cyclone, my low pressure, as counterclockwise. It's the opposite conditions that occur for the anticyclone. So high pressure and low pressure, you really have the opposite features occurring. High pressure is moving clockwise, low pressure counterclockwise. High pressure air is moving outward, low pressure air is moving inward. But both of them reflect the movement of the Coriolis effect. So last part, now we're looking at airflow associated with cyclones and anticyclones. Anticyclones. We need to start talking and using the term aloft. Aloft simply involves air that is found at elevation or at altitude. Aloft means upper airflow. Air converges aloft and sinks, right? It subsides. This is a form of subsiding air. It's moving towards the Earth's surface. This forms high pressure. Once the air reaches the Earth's surface, it flows outward. It diverges outward and is deflected to the right. So notice we're now going to put the whole package, the whole picture together. Convergence aloft. So we're looking at an anticyclone. Air converges aloft. It subsides. It is driven outward at the Earth's surface and deflected to the right. So high pressure is the result of air converges. It has to go somewhere. It goes downward, travels towards the Earth's surface. Where a cyclone is pretty much the opposite of that. Air moves, right? A cyclone here, we're looking at our low pressure system. Air moving along Earth's surface is what we experience. So air is moving inward at the Earth's surface, right? High to low, we've got this pressure gradient force. At the Earth's surface, it can't be pushed into the ground, so it's going to rise. So air at the Earth's surface is converging. It rises. Once the air converges at the Earth's surface and rises, it forms a low pressure. Low pressure is air rising. And once it reaches the Earth's upper atmosphere, or aloft, it diverges. It moves away from itself. It reaches a certain elevation and begins to spread out. So we have cyclones are associated with convergence at the Earth's surface, rising and divergence aloft, whereas our anticyclones have convergence aloft, subsiding air, and divergence at the Earth's surface. Whereas both of them, you'll notice that the arrows are indicating the result of the Coriolis effect. There you have it, people.